Okay, chapter 12. Liquids, solids, and intermolecular forces. The previous chapter we talked a lot about gases. Now we're going to talk about the two other states of matter, liquids and solids. So, have you ever thought about how you taste things? What is it about food that makes something taste sour and something taste sweet? I remember learning about different kinds of taste buds in your mouth, but how exactly does that work? It has to do with the interactions between certain particles in the food and receptors on your tongue. And those interactions send signals to your brain that your brain interprets as different flavors or tastes. So the specific interactions there are between molecules, and so those are called intermolecular forces. They're forces that happen between molecules. So coffee has a bitter taste to it, which I think is why I don't like coffee. That makes getting enough caffeine a little challenging sometimes, but I've been managing okay. But those molecules in coffee that give it a bitter taste interact with certain receptors on your tongue. So intermolecular forces are critical for lots and lots of things. Many of the reactions and the processes that are happening in your body right now that keep you alive are due to intermolecular forces. The very existence of liquids and solids is made possible by intermolecular forces. Without them, everything would be in the gas state, and life as we know it would not exist. So intermolecular forces are really important. Bless you. So whether something is a liquid, a solid, or a gas depends on how strong the intermolecular forces that hold the molecules and particles together are relative to the thermal energy that those molecules have. So higher thermal energy may allow the particles to overcome those intermolecular forces that hold them together. So that's why you take some ice and you add heat to it, you warm it up, and it will begin to melt. It's held in the solid form by intermolecular forces, and as you warm it up, the particles have enough kinetic energy that they can partially overcome those, and the water melts, the ice melts. So we've mentioned before that temperature is related to the motion of particles. So the energy associated with that motion is called thermal energy. All particles, all atoms are in constant random motion. Just like everyone here, although you look pretty still, maybe a little sleepy, everybody's breathing, their hearts are beating, everybody's moving a little bit, right? All atoms are moving a little bit. So if we have something with weak intermolecular forces relative to the amount of thermal energy it has, then that substance is more likely to be a gas. And if the intermolecular forces are strong relative to the thermal energy, it's more likely to be a liquid or a solid.